Welcome to 50-Minute Discourse. Today, we're tackling Earth's magnetic field, like that invisible shield thing. It protects us from all that nasty radiation from space. And because you send in some really cool research articles, the whole shebang. Honestly, it's way more complex than I thought.
You hit the nail on the head. What really grabs me about this whole thing is how it ties into so much. I mean, you got these molten iron rivers deep, deep down inside the earth. And then you got the northern lights, those auroras, just beautiful. And get this, it even affects how some animals find their way around. It's a total story,
Yeah.
about our planet, where it came from and where it's going.
Yeah, for sure. And the big question everyone seems to be asking is, like, is this magnetic field going to flip? And what happens if it does? I've heard that flipping thing, but I never really got what it actually means.
Right. So to get that, we got to start with the basics. Like how does this field even get created in the first place? It all comes down to Earth's core. Now, a lot of folks think it's just this solid chunk of iron, but it's not. There's a liquid outer core, and that wraps around a solid inner core. It's the heat from that solid inner core that gets things moving, like literally drives the liquid iron in the outer core into these crazy, huge, swirling currents. We call them convection currents.
Okay, so we got this molten iron, like, swirling around down there. So how does all that turn into, like, magnetism?
It's kind of wild. It's all about motion and the fact that Earth spins, You got the liquid iron moving plus the whole planet rotating on its axis. That combo creates electric currents. And like basic physics tells us, when you got electric charges moving around, boom, you get a magnetic field. So under our feet, we basically have this ginormous self-powered dynamo.
It's not like there's a magnet just sitting there inside the Earth. It's this whole dynamic, always moving system. Man, this is already way more complex than I thought.
Totally. And all this complexity, well, it means the magnetic field isn't all neat and tidy. It's not stable. It changes in strength. The magnetic poles wander around. They don't stay put. And yeah, it can totally flip, like north and south magnetic poles switching places. The whole shebang.
Oh, okay. Hold on. Before we get to the whole flipping thing, let's talk about these wandering poles. I read somewhere, maybe in one of the articles you guys sent, that the north magnetic pole is, like, looking it towards Siberia. Is that normal, or is something weird going on?
It's both, actually. The magnetic poles, they've always drifted. That's just what they do. But yeah, you're right. The north magnetic pole is moving faster than it used to, faster than historical averages, for sure. It's definitely something scientists are keeping an eye on.
I bet. That already sounds kind of freaky. But I'm guessing the flipping thing is even more interesting. So how does a magnetic flip even happen? Is it like someone just flips a switch, or is it more gradual?
Think of it more like a super slow dance rather than a sudden switch, right? Over like hundreds, maybe even thousands of years, the magnetic field gets weaker, the poles, they start wandering all over the place more erratically, and eventually, yeah, they swap spots. And we know this has happened loads of times before.
Wait, hold up. How do we know it's happened before? Is there some kind of, like, magnetic fossil record or something?
You got it. It's called paleomagnetism. So when certain rocks form, especially volcanic rocks, they got these tiny magnetic minerals inside them. And those minerals, they line themselves up with Earth's magnetic field, like little magnets. So scientists, they study these old rocks, and they can actually piece together the history of the magnetic field, like see how it's changed over millions of years.
So we can literally look back in time and see how the magnetic field has been acting.
That's so cool. So the last time it totally flipped, it's called the Brunhes-Matuyama reversal, happened about 780,000 years ago. But before that, there were times when it flipped multiple times, pretty close together. So yeah, it's kind of hard to predict.
Unpredictable, huh? So that brings us back to the big question. Are we, like, due for another flip anytime soon?
There are some signs, I gotta say, that are making scientists raise an eyebrow. The whole magnetic field, it's been getting weaker for the last 160 years, and it's weakening faster than average. And then there's this weird zone, it's called the South Atlantic Anomaly. Ever heard of it?
Oh, yeah, the SAA. What's the deal with that area?
Well, it's over the South Atlantic, and the magnetic field there, it's super weak, almost like someone punched a dent in Earth's shield, right? And that dent, it's getting bigger, and it might even be splitting. Some scientists think it could be linked to stuff happening way down in Earth's core, maybe even connected to a future flip.
So a weakening field, poles going all over the place, and this growing anomaly. It sounds like things are heating up, both literally and figuratively.
Makes you wonder what's brewing beneath our feet, right? But before we jump to any conclusions, let's look at the evidence a bit closer and see what the scientists are saying.
Okay, so we've laid the groundwork. Now it's time to dive deeper into the data. But hold on. Before we do, I think we need to talk about what could happen if the field actually flips? I mean, if our shield gets weak, what does that mean for us? Are we all going to get fried by cosmic rays? Like, is it a doomsday scenario?
Whoa, hold on. It's not quite doomsday, but there are some serious things we got to think about. Some potential consequences, for sure.
All right, hit me with it. What's the worst case scenario? Like, what are we looking at here?
So during a flip, when the magnetic field is weak, we'd be way more exposed to these charged particles, coming from the sun and from deep space cosmic rays. And that could mess with satellites, communication systems, even power grids. And yeah, we might get hit with more radiation, which could be bad news for people and the environment.
Yikes, that sounds pretty bad. Has anything like this happened before? I mean, do we know what happened the last time the field flipped?
It's tough to, draw a straight line from past flips to specific events, but there's no proof they caused any mass extinctions. Life on Earth, it's tough, it's been through multiple reversals and come out the other side, but that doesn't mean there wouldn't be problems.
So maybe we won't go extinct, but things could get messy. But hey, scientists are keeping an eye on all this, right? So there must be ways to prepare for a flip if it happens.
Absolutely. The more we understand what's going on, the better we can get ready, like designing tougher satellites, making our power grids more resilient, getting better at predicting space weather, stuff like that.
Knowledge is power, right?
Yeah.
And speaking of knowledge, we've covered a lot of ground here. We talked about how this magnetic field gets created, how it changes over time, and what could happen if it flips.
And we've only just scratched the surface. There's so much more to talk about, like how animals use the magnetic field to find their way and whether a flip could cause these crazy auroras visible all over the world.
What's one big takeaway you think people should remember about Earth's magnetic field?
I'd say the most important thing is that our planet is constantly changing. It's dynamic, it's alive, and the magnetic field, that's just one example. We shouldn't be scared of these changes. We should be curious about them. They're a chance to learn more about our planet and how to take care of it.
Well said.
So now let's really dig into what scientists are seeing and try to figure out what's real and what's, just speculation.
Okay, yeah. So last time we talked about the magnetic field getting weaker, the poles kind of going crazy, and that South Atlantic anomaly. What else is catching the attention of scientists? Like, what are they really focused on right now?
One thing that's causing a lot of buzz is the movement of those reverse flux patches we touched on earlier. Basically, there are these areas like on the border between Earth's core and its mantle where the magnetic field lines. They point the opposite way from the rest of the field.
Right, right. It's like little pockets of reverse magnetism inside the core. Are these patches a new thing, or have they always been there?
They've always been around. It's part of how the magnetic field works. But the thing is, they seem to be growing and moving faster now. And some scientists think this could be a sign, like a warning, that a bigger magnetic reversal is coming.
So it's like these patches are cracks, and maybe the whole thing's about to break.
That's a good way to think about it, but we got to remember the science is still developing. Scientists are still debating how these patches actually affect the whole magnetic field and if they're a reliable sign that a reversal is coming.
Okay, so it's not a simple thing, but it sounds like those patches are definitely something scientists are keeping a close eye on. What other clues are they looking for?
One really cool area of research is comparing the changes we're seeing now to what we know about past reversals, from paleomagnetism. By looking at the patterns and the timing of past flips, scientists are trying to figure out if we're on a similar track.
So it's like looking for historical rhymes, seeing if history is repeating itself. What are they finding?
There are some interesting similarities. For example, during some past reversals, the magnetic field strength decreased at a rate kind of like what we're seeing now. And there's evidence that the magnetic poles went kind of nuts, wandering around like the North Magnetic Pole is doing now.
That sounds a little spooky. Were there ever times when the field got weak but didn't actually flip?
Yeah, actually. They're called geomagnetic excursions. It's like the field dips, gets weak, the poles shift, but then they eventually go back to where they were. A good example is the last Champ event, happened about 41,500 years ago.
So even if things keep going the way they are, there's a chance it could just be one of those excursions, not a full-on flip.
Exactly. That's why it's super important to look at all the evidence, not just one or two things. Earth's magnetic field is complicated, A lot of things can affect it, and we're still trying to figure it all out.
It's like trying to solve a puzzle, but the pieces keep moving around.
Yeah, that's a great way to put it. And that's what makes this research so exciting. Scientists are using all these fancy computer models, and they're constantly getting new data, trying to put the pieces together, trying to understand what the future holds for Earth's magnetic field.
While they're doing that, let's talk about what could actually happen if a flip does occur. You mentioned problems with satellites, communication, and power grids. Can you tell us more about that?
Of course. When the magnetic field weakens during a flip, it's not as good at blocking those charged particles coming from the sun. And those particles can mess with our tech, with our atmosphere, in all sorts of ways.
Like what? Give us some examples.
Well, satellites, they can get zapped, their electronics get damaged and they can malfunction or even totally fail. Communication systems, they can get disrupted. Radio signals get messed up, blackouts, that sort of thing. And power grids, they can get overloaded, like transformers and stuff blow out, and then you got widespread power outages.
So it's not just our compasses going haywire. It's our whole infrastructure that could get messed up. The stuff we rely on every day.
That's right. And that's why it's so important to understand these events and be ready for them. If we invest in stronger infrastructure and come up with ways to handle these risks, we can minimize the problems.
What about, like, our health? You mentioned radiation. Should we be worried about that?
Yeah, it's something to think about, but let's not freak out. I mean, we're exposed to low levels of radiation all the time just from natural sources. During a flip, that exposure might go up, but it's unlikely to be some kind of disaster. Still, we got to keep an eye on it and understand it better.
So, no need to wear lead suits, but it's something to keep in mind.
Exactly. It shows how important research and monitoring are. The more we know, the better we can protect ourselves and our planet.
Okay, so we talked about the science, the evidence, and what could happen. But I'm curious, what do you think? Do you think a flip is going to happen soon? And are we ready for it?
It's impossible to say for sure when or if a flip will happen. The data tells us we're in a time of big changes, but these systems are so complicated it's hard to predict what they'll do. As for being ready, I think we're getting there.
What makes you say that?
Well, more and more people are realizing how important Earth's magnetic field is and how it could be vulnerable. Scientists are making huge strides in understanding it, and we're seeing more investment in research and infrastructure to, try to prevent problems.
So we shouldn't get complacent, but there's hope.
For sure. I think that if we use what science tells us and plan ahead, we can handle whatever challenges a magnetic flip might throw at us. We can make sure humans and our planet have a bright future.
Now, for this last part, let's get into the really crazy stuff, like how animals use this invisible force, this magnetic field, to find their way around.
This is where science gets almost like magical. We've known for a while that some animals have this crazy magnetic sense. I mean, think about it. Migratory birds, they fly thousands of miles across whole continents and oceans. Sea turtles, they navigate these huge distances to get back to the same beaches to lay their eggs. Even bacteria, tiny little things, they use it to orient themselves. It's wild.
It's like they have a built-in GPS, but way more advanced than anything we've got.
Yeah.
So how does it actually work? Do they, like, have a magnetic sensor in their brains or something?
There are a few different ideas out there, and it probably depends on the animal. One of the main theories is that some animals have special cells, and these cells have magnetite in them, which is a naturally magnetic mineral. So these cells, they're like tiny little compasses. They line up with Earth's magnetic field and tell the animal which way to go.
So they literally have tiny compasses inside them. That's insane. What about animals that don't have those magnetite cells? Are there other ways to sense the magnetic field?
There's another really cool theory that involves cryptochromes, which are these light-sensitive proteins. You find them in the eyes of some animals. The idea is that Earth's magnetic field can actually affect these cryptochromes, and that triggers some chemical reactions, and those reactions give the animal directional information.
Whoa, so they're basically seeing the magnetic field. My mind is blown right now. Okay, but let's get back to our main topic, those magnetic flips. If animals use this magnetic sense to navigate, wouldn't a flip totally mess them up? Wouldn't they be lost?
That's a good question. And scientists are definitely looking into it. But it's probably not as bad as you might think. Remember, these flips, they happen gradually over a long time, hundreds, maybe thousands of years. That gives animals time to adapt.
So they could, adjust their magnetic sense as the field changes.
Exactly. Plus, a lot of animals that use magnetoreception, they also use other things to navigate, the sun, the stars, landmarks, ocean currents, even smells. It's like they have multiple backup systems.
Okay, so they wouldn't be totally screwed. But navigating a changing magnetic field, that still sounds pretty tough. Do we know for sure if animals have been able to adapt to past flips? Do we have any proof?
Well, we can't go back in time and watch what they did during past flips. But the fact that they're still here, they're still migrating, still finding their way around, that tells us they figured it out. Evolution is pretty amazing, Life finds a way.
That's good to hear. Seems like life can handle these big planetary changes. It's pretty resilient.
And speaking of big changes, let's talk about one possible effect of a flip that's gotten a lot of attention, the chance of seeing auroras all over the place.
Yes, this is what I've been waiting for. I read that during a flip, we might be able to see auroras, those beautiful lights in the sky, way further south than usual, like not just at the poles.
It could definitely happen. Remember, auroras happen when charged particles from the sun hit Earth's magnetic field. And during a flip, when the field is weaker, those particles could get deeper into the atmosphere, and that means auroras could happen at lower latitudes.
So imagine seeing those amazing lights, not just in Alaska or Iceland, but maybe over New York City or London. That would be incredible.
It would be a sight to see, for sure. It's a bit speculative, but it's one of those things about a flip that really gets people's imaginations going.
Yeah, for sure. It shows how everything's connected, from the molten iron deep inside Earth to those beautiful lights in the sky.
Exactly. And I think that's one of the big takeaways from our deep dive. Earth's magnetic field, it's not just some abstract thing. It's a powerful force that shapes our planet, it protects life, and it even connects us to the universe in ways we're just starting to understand.
Well said. Well, folks, that brings us to the end of our deep dive into Earth's magnetic field. I hope you've enjoyed exploring this with us. It's been a wild ride.
We've covered a lot of ground, from the molten iron deep down to those wandering poles, the possibility of a flip, and even how animals use this invisible force to navigate.
That's amazing, all the wonders and complexities of our planet. And it definitely leaves us with more questions than answers, which is always a good thing, I think.
I agree. So, to all our listeners out there, keep exploring, keep asking those questions, and never stop learning. The more we understand about Earth's magnetic field, the better we can appreciate it, and the better we can protect this incredible planet we call home.
Couldn't have said it better myself. And hey, if you enjoyed this deep dive, don't forget to hit that like button, subscribe to our channel, and share it with your friends. Let's keep the conversation going. Thanks for joining us on 15-Minute Discourse. Until next time, stay curious.